In this tutorial, I'm going to go over the classifier filters and how to configure them. And we'll start off with this 5-band scenario. And what we have here is packets are coming in from both interfaces. And the packets are going to go through a classifier. And the classifier is essentially a router that is going to route the packets to one of these 5 bands. And you can see here these gauges indicate whenever there is packet activity. And also there is a shaded tip on some of these arrows indicating that a classifier is sending packets to that band as part of its filter configuration. So let's click on the center icon and go to the network graph page. So packets will be coming in on the left and entering the classifier, where it's going to route the packet to one of these bands depending on filter configuration in the classifier. So if I click on the classifier, I can then add some filters, and what I'm going to do is I'm going to add filters from our pre-configured library. I'm going to add a filter that detects ICMP packets and a filter that detects UDP packets. In this case, going to a destination port of 5060. I'm going to add those 2 filters. And then in my case, I'm going to customize this second filter that was added. This filter is pre-configured to detect packets going to port 5060. I'm going to edit it. And in the IP port section, instead of 5060, I'm going to detect packets to 5201. And these are going to be UDP packets. Hit apply. Close. And for these packets going to port 5201, that's actually going to be a from my iPerf test tool. So I'm going to forward these packets to flow 2, and I'm going to label flow 2 as my iPerf 3. These packets up here, ICMP packets, will be detected by this filter, and I will send those packets to flow number 1, and I will rename this flow ICMP. And now I will enable the classifier. And so the way this works is the waterfall mechanism. A packet comes in, and it is compared one at a time to each of these filters in the order that they appear. Once a packet matches a filter, it will be forwarded to the flow indicated here, and then all further matching stops. And so the filter is, each packet is compared to one filter after the other, and if there are no matches, then this final else clause will send the packet to the default flow. So if I go back into the network diagram, what we have here is the classifier will compare each incoming packet to each filter in a row. And if the packet matches no filters, it goes to this top band where we have 2 default flows. But if the packet is an ICMP packet, it'll go to this band. If the packet is an iPerf 3 packet, it'll go through this band. So we can actually test that out. Start with the ICMP. If I ping on my left side to the server on the right side, what you can see here is this meter gauge has just gone up. As long as there are a non-zero number of packets, then you will get at least the smallest meter gauge indication. So that indicates there are ping packets going through this particular band. Now, likewise, I can start a iPerf 3 server on the right side, which is listening to port 5201. And since I have a filter in this classifier that detects packets going to port 5201, if I then send UDP packets across, then you can see here that the gauge lights up for the packets going from my iPerf 3 client. And in this case, you can see, you can eyeball it, and it's sending a little over 10K bits per second from my iPerf 3. Now these hook labels that we have here indicate what's been configured in the classifier. If a hook label says default, it means that if a packet matches no filters in the classifier, the packet will be forwarded to that band. And in fact, the top band is always the default band, and it will always have a default label. A label of active indicates that there is a filter configured in this classifier that will forward packets to this band under certain circumstances, and the filter is fully enabled. If a label says unused, it means that no filters in the classifier forward to that band. Okay, so now I'm going to go in and explain how to further customize some of these filters. For instance, for this filter, we have the ICMP filter. I can, in fact, give it a custom name here. It's just a memo. And I can also enable or disable that filter individually here. If I disable it, then the filter is basically ignored. If I go in here and I can also change the order of filters by dragging and dropping. So now the ICMP filter is last, so it will be compared last. If I go in and edit this filter, let me go back to the IP layer. So initially, the only thing that's enabled on this filter is this ICMP checkbox. And a packet that is an ICMP packet will match this filter. Now, the filter criterion here is what we call a AND of ORs. And what that means is that you have these subsections like the source address, destination address, protocol. And within each of these subsections, a packet will match if any of the criteria match, which is the OR criteria. So if I checked TCP, UDP, and ICMP, then the filter would match if the packet was either a TCP or UDP or an ICMP packet. But then outside of the sections, the logic is an AND. If I set values for each of these sections, then in order for a packet to match, the packet would have to satisfy all the subsections, this subsection and this subsection and this subsection. If I go back to what we had here before, I can now add further criterion. For instance, entering an IP address. Typically, you enter an IP address, and then you must also enter a mask. If I just click here, I get the mask with all ones. I can specify any pattern of 1 bit. Any bits set to 0 are don't care bits. However, it's important that if you do set don't care bits corresponding to 0, then you must have a corresponding 0 bit in your address. And if you don't, you get this little icon that says that you have 0 bits in the mask where there are 1 bits in the address. And you just click on that to fix it. It will then just add the 1 bit to the mask to fix it for you. And it is possible to enter a multicast address, and then you will get an icon here indicating that you just entered a multicast address. So I can enter any number of up to 3 IP source addresses. Now, for the ports, instead of a value mask, we have a range list. So I could say trigger this match for this filter if the packet goes to port 80 or anywhere between port 80, 80, and 9000, for instance. And maybe also port 10,000. So it's a list of any number of values and or ranges. Likewise, for the protocol range list, I could say 1 to 8, that sort of thing, and it will trigger if any of these are matches. Now, in the advanced options, this is pretty self-explanatory, but if I want to trigger on the quality of service, I enable this, and then we have DSCP bits, and I can trigger for a value mask for DSCP and ECN. Now, if you're unclear about what numbers or ranges to use, just hover over this question mark icon, and then in the bottom at the bottom of the dialog, you'll see a info line. It'll tell you what the minimum and maximum is, or you can click on it and get a little bit more information about the item and also the minimum and maximum. Also, if I click in the mask area, it will automatically fill that mask with all ones. And so my DSCP bits are, in fact, the value ranges from 0 to 3F, so I could enter like 0x20. For ECN, it's just 2 bits, so I could enter that. I could require a check of the don't fragment flag, and then I can require the don't fragment flag to be on or off, similar to the more fragments flag. And then we also have value and range lists for the various other fields in the IB header, like 60 to 1000 or 2000, that sort of thing. And then for the IP layer here, if we switch to IPv6, it switches over to an entirely different slate of values. My IPv4 values are still remembered. I can go back and look at what they were. But if we're matching against IPv6, then we can go ahead and enter any valid IPv6 address in any format, like : is a valid address. And similar to IPv4, if you just click in the mask, it fills it with the equivalent of all ones. Same deal, similar configuration here. For any subfilter, I can either enable or disable that subfilter. I can also enable or disable the entire filter. Now, if I cover the lens section quickly, we have a similar deal where I can enter a MAC address, click to get all ones. Same thing, I can enter don't care bits. If it complains, I can fix it. And also, if the least significant bit of the most significant byte is 1, that is a group address, and I get a little G icon, which is handy. Let me enable this subfilter here. For Ethernet 2, the ether type is generally going to be 0x0800 for IPv4. There are also values for IPv6 and ARP, that sort of thing. But typically you won't be using this because you'll probably mostly be using Ethernet 2, and you'll be using other parameters to do the filtering criterion. Same situation, you can trigger based on a VLAN tag, and whether or not there's an MPLS shim between your Ethernet layer and IP layer, and you can specify parameters for that. Once again, using the question marks to get a little more information about what to use. Going on to the match subfilter. This is where you can match against a particular value at a particular location. So I could say, for instance, in the IPv4 payload, at offset 40 bytes, check to see if the actual value in the packet is equal to 0x290 with a mask. And once again, I entered a too many digits there. Max value 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay, now I got it. Once again, with the do not care bits, optionally fixing them for you. Now, in this case, you have up to 5 line items that you can enter. And in order for a packet to match this filter, the packet will have to match all of the line items for which you have parameters. So this is a AND operation of all of these. And if I drop down and hover over, or if I select a different a payload type, then in the upper right-hand corner, I get a little icon indicating the layout of that packet. So after I've configured the filter the way I want it, let me go down here, apply, close, And actually, it double checks to make sure I really wanted to keep that IP layer disabled, and I do. And then you can go down here and verify in this summary the items that you configured in that filter. For instance, in the LAN subfilter, we did in fact enter these MAC address and masks, and we did in fact disable the IP layer. And for that matching section, we did have one entry with this configuration. So it gives you a nice summary of how you've configured that filter. Now, if we go back in to this filter, one of the features of KMAX is that you can then convert these basic parameters into an expert expression mode by pressing this button. And what comes up is the filter expression that represents those previous parameters that we just entered. Then you can go in here and edit it by hand to create a highly customized, more advanced filter expression. Now, the key thing to note is this pound sign. Everything before the pound sign is standard PCAP TCP dump syntax. And if we go to this icon, and if you click on this link, it'll bring up a web page with the syntax that you need to use for standard PCAP TCP dump. Everything after the pound sign is Interworking Labs special syntax, which is much more efficient for certain things, especially byte matching. And you can go to our online help, and there's a full write-up of the syntax that you can use for everything after the pound sign. It's actually a stack language. And what I can do is, if I were to go in here and edit it, and if I were to make a mistake, like that would not be allowed, and then I change focus, it will come up with an error message to indicate what's wrong, and then I can go back in and fix it. And I could apply this, and if I exit, it then tells me that, okay, this filter now is using a PCAP expression that I've just entered here. And I could go back in, and if I switch to basic mode, I have the choice of either using the previous basic parameters that I entered or starting completely from blank. The system is not able to translate the expert expression I typed in back into basic parameters. You can go one way but not the other way. So if I were to start with a blank filter, everything here is blank, I could go back and say just enable this subfilter for UDP. And that's what we have here. Now, typically when I'm testing streams that are going through the impairment network, what I will typically do is have a client packet generator on one side and a server or packet reflector on the other side. And then I will create filters that forward the data packets through one of the non-default bands. And then I will still be able to connect to my separate client or server machines through the default band, such as Telnet or SSH. And then what I can do is set impairments on the data flowing between client and server, say duplicate. I could enter a duplicate criterion. And that way the data packets between client and server are impaired, but not my SSH connection that I'm using to control my client and server, which is quite handy. And then just be aware that if you turn on the bypass switches, the packets will completely bypass the classifier entirely. So in this case, packets would not be going through the classifiers or the center network at all. And if I go back to the dashboard, I can see that in my dashboard I now have gray-tipped band arrows, which indicate that there are filters configured in the classifier that forward packets to these specific bands.